So far, you've seen the basic intuition behind local expressions, and you've seen how the concepts of lexical scoping and scope contours allow us to know exactly which definition provides the value for a constant reference or a function call. But we don't yet have a precise model for how local is evaluated. And without that model, we can't know the exact value of locally defined constants when they appear inside of function definitions. So what I'm going to do in this video is show you the exact evaluation rules for local, and we'll just work through that step by step. And this is going to be really important for the way that we use locals when we get to function abstraction. In this video, I'm going to talk about the actual evaluation rules for local expressions. And I'm going to do that because it'll help you understand some of the ways that we're going to be making use of local in function abstraction a little bit later in the course. So here we go. I've got another example here. This one is slightly simpler than the super complicated one we saw last time. But it's complicated enough to talk about what we need to talk about here. So, intuitively we could see what's going on here. That B and that B are the outer B, and both of those inner B's are the inner B. So that's plus 1 times 2, 2 is 4, so plus 1, 4, and 1. Pretty sure that's 6. It is. But let's talk about how ISL actually evaluates the local expression. So the first thing to remember is that local is an expression. It doesn't affect the evaluation of expressions outside of it. All expressions are like that. So let's start by evaluating this whole expression. Open paren plus. Plus is the name of a primitive operation. So this is a call to a primitive operation. We need to reduce the three operands, this B, this local expression, and that B, to values. We start with the first one. Is it a value? No, it's not. It's a reference to a defined constant. We happen to be using lowercase names here, but that's a style guide issue, not a language issue. So B is going to be replaced by 1. So the first evaluation step is just that B gets replaced by 1. Nothing's happened with the local yet. We haven't seen it yet. Okay, now let's do this local. Now the way local evaluation works is that 3 things are going to happen in one step. Okay? There's going to be a thing called renaming. There's going to be a thing called lifting, and then we're going to replace the entire local expression with its renamed body. Let's first talk about the renaming. The first thing we do is we take every definition in the local, in this case there's just one, define B, and we find all the references to that definition. In this case there's these two. We can either do that ourselves or we can use check syntax to help us. There's those two definitions. And now we come up with a new, globally unique name for B. What I'll do is I'll make a copy to work in. Just to keep it simple, what I'm going to do is I'm going to rename B to B_0. And at the time I do that, I'm going to rename all the references to B to B_0. Now, if B_0 already existed, I would use something else. The key thing is it has to be a unique name. There can be no other definition in the world that has this name. Okay? Technically, it's actually, there could be no other definition in the top level scope that has this name. And technically, actually, the renaming works in a more subtle way. But this explanation is good enough to understand the evaluation of any program we're going to write. Now that I've done the renaming, I do another thing, which is that I take the renamed definition and I lift it out of the local so that it's now in the top level scope. And notice I don't lift it just out of the local. I didn't put it here. I did not put it there. I have to lift it all the way to top level. I lifted it all the way to top level. If you want, you could go put it all the way up here with the other definitions. You don't have to do that. It really just has to go to top level. So I did the renaming, I did the lifting. Now the third step is I replace the local with the body in which the renaming has happened. And now notice something important. There's no local anymore. The local is gone. That's the same kind of thing we saw with if and cond. If tried to get itself out of the way. It evaluated the question, and then it replaced itself with either the true answer expression or the false answer expression. That's what's happening here. The rules for evaluating local are trying to make the local go away so that it'll have a program in BSL. This is now a BSL program. It's not an ISL program anymore. Local is gone. And so now we just keep evaluating. And of course, since it's a BSL program, it's quite straightforward. Let's see, which B0 is this? Well, it's that B0. So this will become, in the next step, that B0 will become 2. In the step after that, the next B0 will become 2. In the step after that, the times 2, 2 will become 4. In the step after that, this B, well, which B is that? That's this one way up at the top here. That's going to become 1. Whoops, I need to actually do the step. Yeah, that's going to become 1. And in the final step, that whole thing is going to become 6. The key thing about the step-by-step evaluation, or about the evaluation rules for a local expression, is when you get to the local, first you rename each definition and all of the references to a globally unique name. So if there were multiple definitions here, you would do this for all the definitions. So in this case, we renamed B to B0. You rename the references also to B0. Then you lift the definition to top level. There it is. And then you replace the local by its body. So that's the rules for evaluating a local. Rename, lift, replace the local with its body. Be sure to practice that, because understanding how we're going to use local in abstract functions is going to require having this understanding of local. You need to understand how to form a local, you need to understand the rules of lexical scoping, the contour rules, and you need to understand the rules for evaluating a local. Just practice it and do these exercises coming up.